The Multichannel Organics In-situ Environmental Analyzer, referred to as the MOIRA system, was developed through the NIH's University of Louisville Superfund Research Center for mobile measurements of airborne volatile organic compounds, or VOCs. The instrument is capable of 5 to 10 minute time resolution measurements of VOC concentrations down to tens of parts per trillion, as tested to date. The instrument was designed for in-situ field operation with a modest footprint, low power consumption, and robust hardware and electronics. The MOIRA system is based on gas chromatography mass spectrometry, or GC-MS. Gas chromatography separates compounds, and mass spectrometry identifies compounds based on their molecular structure. Various molecules, or VOCs, gas phase compounds, can be emitted from different sources, indoors or outdoors in our environment, and I'll represent those by different colored dots. The MOIRA system will use a concentrating trap for several minutes. We'll collect these molecules and concentrate them, and then it will heat them up and deliver them into a GC mass spec system. As it heats up, the most volatile compounds, let's say blue, will come through first, and the mid-volatility compounds will come next, and then the lowest volatility compounds will come later. And what that looks like on the mass spectrometer then would be a blue peak coming through, purple peak, and then our red peak. The mass spectrometer at any given point here, as the molecules are coming in, it will bombard those molecules with electrons and create a mass to charge fragment pattern based on the structure of the molecule. And these fragment patterns can be used as a fingerprint for each of the individual molecules. The MOIRA system is composed of 4 different focusing traps and 4 different GCs and 2 different mass spectrometers, where the GCs and the mass specs are miniature and lower power consumption, which makes them amenable to portable field deployment. With sampling and analysis steps overlapped amongst the 4 channels, that allows as low as 5-minute time resolution between samples.
At any given time, one of the 4 measurement channels is collecting a sample. So first, the Teflon filter removes any particles from the sample, leaving the gas phase volatile organic compounds, which are collected by sorbents that are packed into a custom trap designed by our collaborators at Aerosol Dynamics Incorporated. After sampling is complete, the trap is rapidly heated up, and then helium is sent in the reverse direction to transfer the collected organic compounds from the trap to the gas chromatograph. Next, the GC is heated up gradually, and this separates each of the individual compounds from each other by boiling point. The GC column that we use is a 30-meter column. Here we have it wrapped in a single layer on this aluminum hub that conductively heats the column, saving both space and energy. This helps us get to a reasonable physical footprint and power requirement, even when we have 4 gas chromatographs in the system. The compounds exit one by one from the GC and go through this transfer line into the vacuum system, more specifically into the source of the mass spectrometer. The mass spectrometer fragments the compounds into a characteristic fingerprint, enabling us to measure both target and non-target compounds. At any given time, 1 channel is collecting a sample, 2 channels are doing GC analysis, and a 4th channel is either preparing for GC analysis or cooling down afterwards. The synergies of combining multiple channels into a single instrument enable an overall lower physical footprint and power requirement, as well as the operational advantages of a single control system for the instrument. MOIRA was specifically designed for mobile deployments in a vehicle with vibration isolation, power optimization, safety features that were built into both the software as well as into hardware interlocks that protect the vacuum system in particular, as well as general mechanical robustness.